Alright, so let's work through another example here of a distributed load. This time the distributed load is, it's a uniformly distributed load, but it's not across the entire section. So we'll just figure out kind of what the resultant is and find our reactions at A. So we have our cantilever beam. So let's go ahead and draw a free body diagram of that cantilever beam. So we are going to have some sort of supports at A, called AY, AX, and we're also going to have some sort of moment reaction, MX, sorry, MA. So we got that. Got this 4 kilonewton force here that's acting at 1 meter from A. And we have this force here that is distributed over the length. So what's the magnitude of the resultant of that force? Well, so that'll be 1.5 kilonewtons per meter times 2 meters, 3 kilonewtons. Where is it going to be acting? Well, it's going to be acting directly smack dab in the middle of this distributed section because it is a uniformly distributed section, and the centroid of a box is in the center of the box. We know that. So that is going to be acting 1 meter from this end, or alternatively it'll be acting 3 meters from A. Alright, so now we got enough information to solve for reactions. What's the first one we're going to solve for? Let's do the easy one first. Sum of the forces in the x direction is 0, which is equal to AX. Cross that sucker out. Don't need it. Unnecessary. Next thing we're going to be doing here is, I guess, the moment reaction. Sounds reasonable. So the sum of the moments at A is going to be equal to 0. So that is going to be equal to, I put this as a positive moment reaction here. I often do that with unknowns deliberately, but in this case, if I don't have a sense of what the direction of the reaction is going to be, but in this case, it would be in that direction, since it needs to pose both of these forces that are going to be causing clockwise in the other direction. But anyways, we got our MA. And then that is going to be minus the 4 kilonewtons. What are we doing? Times 1 meter. And again, it's minus because that's going to be causing a clockwise rotation about A. Same deal with our 3 kilonewton force. So 3 kilonewtons crossed with 3 meters. Gives us MA. So we can just move the MA, move the other ones over to the other side, leaving us with MA. So that'll be what, 4 kilonewton meters plus 9 kilonewton meters, which means that MA is going to be 13 kilonewton meters. So there we go. We've got one reaction left. So that one's fairly easy to solve for too. Sum of the forces in the x direction is equal to 0, which means that the only forces that we have is our AY and the 4 and 3 kilonewton forces. So AY is depicted as positive there. So AY minus 4 kilonewtons minus 3 kilonewtons. Therefore, AY is equal to 7 kilonewtons. Now that's all we got for our reactions. I don't know why I'm humming the chicken song. $13. So there's our free body diagram with the supports in place. You could add the little arrow for 0 if you want, but I don't see the point. All right, and we're done.